Alright, hello everybody, and today is another stream of development on a game, my real-time strategy game in Unity. So where we left off yesterday was we had this, or I had this the landscape basically, but the problem is that I'm going to solve today is that if you made it a bit bigger, then a bug happens. And right now it looks fine, but if we look in the sort of inspector here, right, so it looks all right until you see these lines, and if we look below, you can see that's not how it's supposed to be. And the reason for that is because of the Unity vertex limit. So there's a limit on how many, basically there's a limit on how many vertices one can have in a Unity project, and in this case it's 65,535. So why is this a problem? Well, I just made a too big mesh. So if you can see here, 300 by 217, we can just look here, 300 times 217, that's 65,100. And that's just the tile width, but the number of vertices, we add 1 to all of these, to both of these values. And as you can see, this is bigger than 65,535, and this is smaller, which is why the bug occurred on this specific value. And you know, if we wanted to test this more, we could see like this, so this shouldn't have a problem, and we can test that. So if we just put this down to 299, it should be perfect. It should still be perfectly fine. And take a look. Indeed it is. There is no sort of weird artifacts or weird stuff going on. So that is what I'm trying to fix today. And I have an idea on how to fix it. It's going to involve some weird Unity stuff, but I think it's going to be alright. So the way I've got it now is I've got something called a world renderer. So I have a world renderer, and make text bigger. Make it bigger, please. Okay, so we have a world renderer, and what the world renderer does is it essentially creates a bunch of vertices. We can make a really big brush here. So it makes vertices, and then it connects them with triangles. So we do we could have a bit of a different sort of thing here. So as you can see, we sort of connect them with triangles like this, and then that we do that for all vertices basically. So that's essentially what it does. And so, you know, it kind of makes a shape like this. And we have that, and we do that, you know, drawing skills, like always. So we have all these triangles, but when there are more vertices than the vertice limit, then there's a problem. So this is the new plan, how it should work. So here we have the new world renderer. There we go. And how it's going to work is that it's going to have a grid. Well, that's a bad way to represent a grid, isn't it? So we have a grid of smaller components, and each of these components have a bunch of vertices that are connected by triangles. And this is how it's going to work now. So we're going to have all of these sort of sub-components, and together they're going to form the world. And so each subcomponent is not going to go over the vertex limit, but together they might. But that's not going to be a problem, because none of them individually go over the limit. Of course, they're going to be much bigger than 3 by 3. They're going to be like, let's see here. So, right, so we could just do squared. That doesn't work. I'll just do that. Why don't you do math, man? Man. What's going on? +4. Okay, so something is clearly wrong, but let's get up a calculator here to find. Calculate. No, there's no calculator. Oh, damn it. Okay, I just have to figure out the values on my own then. Fine. Okay, so let's see what we can do. So in the world renderer, this is not going to be here any longer after this. So what I'm going to do is I'm going to add a new class. This class is not going to be public, and I think it might even be a subclass of world renderer to get the hierarchy right. So we don't want anybody else to see this. This is just like a private thing for the world renderer. When we access it, okay. So yeah, sorry, but if there's some buffering right now, I see that on YouTube. There's buffering issues and stuff. Hopefully, okay, now it's good. Great. So we want to have a world section, I guess, or like a renders a mesh controller, I guess. So we're gonna have multiple mesh controllers. So what are they going to have? They're going to have a game world. That's something that they always want. We want a mesh called controlling, and we want a mesh collider, which is the collider that we're controlling. And we're also, of course, going to have some other things like color 32, vertex colors. Right, we can just copy these values. And they're also, which is important. Wait a second. Why am I having vertex colors and colors? That doesn't make sense. I don't need these vertex colors. That's weird. Why would I have those? Oh. No, I do need them. Okay. And so we want a public mesh controller. So let me just explain what the mesh controller is going to do exactly. So let's make a new sort of paint thing, and so this is like the mesh controller that we want. So it's going to, let's see here. So it's going to take a world, so have our massive world, right? So a massive world, right? So it's like 1,000 by 1,000, so it's massive, absolutely gargantuan. Fancy words. And so what the thing is going to do is it's going to be a subsection of this world. And so let's take a closer look at this subsection. So the subsection might be something like 250 by 250. So not too big. And so in this case there's going to be 4 subsections. Just going, so you know, there's 4, and then there's going to be 4 down here as well. And each of them is going to be one of these. And this of course has all of the vertices, you know, tons of vertices, and then triangles and stuff like that, you know, there's tons of stuff. I'll just get rid of those to make it more clean. So how is this going to work? Well, it's going to have a top. So it's basically going to have the coordinates of this place. So it's going to have an x0, y0. This is horrible. Let's make a smaller pen and try to redo that. So x0, y0, and that is really small. Whatever, I mean, okay, that's fine. Just redraw that. Okay, and here I have x1, y1. And so these are the coordinates of the point here and the point here. So all of the other coordinates can be derived from here, and of course x0 plus 250, that's x1. Because we go 250 steps to the right, and then we get x1. We go from y0, we go 250 steps down, we get y1. So you know, we can calculate the width and so on. For example, so width equals the x1 minus x0. And the same thing with the height, it's just y1 minus y0. And this is going to be quite handy, because other things we can do is we can, for example, disable a certain section. So for example, if we don't look at certain sections, we can disable them. So for example, here we have the camera, so it's looking here. Then we can disable these sections and get some better performance. So we want to try and balance the sections to get them perfect size. 250 might be a bit large, so maybe something like 100 by 100 would be preferable, because then we can do more precise things than just we can disable more precisely and save even more rendering time. But of course, doing something like 1 by 1 will be more inefficient, because then we're going to have so many, it's not going to be worth even having this sort of system at all. So, you know, there's sort of a balance there to be had. Anyway, let's see what we can come up with. So I also want a game object called the object, or well, sort of container, I guess. So this is what contains this mesh controller. And so let's just say container equals a new game object, and it should instantiate a new game object. And I think we should also put something like int top, or let's see, left, right, top, bottom. So we can get all of those values. And we should also pass them in right here. And so what this game object's position is going to be a new vector 3. I think you can give a position for a okay. So we need first a string, a name, and then we can give it some components. Well, I guess I could give it some a mesh renderer and a mesh filter. Type of mesh renderer, type of mesh filter. And so those are the different components that we want. We might want some more, like a type of mesh collider, and then we can of course set them. So we can say controlling equals container dot get what is going on, get component mesh filter, yes, dot mesh. And of course the mesh renderer, we don't need to do anything with it. well, maybe we'd want a material though. So maybe material, the world material. Well, I guess just material. Okay. And so now we can just say, for example, a container dot get component mesh renderer, and we want to give it a material, which is the material. So give it. So now we just set the material that we want it to have. And now we should also calculate some other things that might be handy. For example, the width and the height. So let's just set our properties. So left equals left, right equals right, right, this dot top equals top, this dot bottom equals bottom, and this dot width equals right minus left, and this dot height equals bottom, no, top minus bottom. And we of course don't actually need those things, and it says that there as well, so let's just remove those. So we get those. Let's see what more we need to set. So we need to set our vertex colors equals the width times height. So we're going to need a new color 32 with the width times height, and we also need some vertices equals a new vector 3 array with width times height. We also want some triangles. Well, these are going to be the colors, not the vertex colors. That's important. So you don't want to set those here. And then we want one more thing, which is the triangles. And it's going to be the width times height. However, it's going to be the width times height minus 1, because that's how it works. I know that just, no, yes. And then we're going to multiply that by 6, because that's exactly what I've got here. I'm just, this is just the number of tiles there are on the sort of map thing. And now we want basically this exact same thing. We just want it to work a bit better, or well, it just does exactly the same thing. There's no sort of difference with it. And I also want to just move down this class to the bottom, so that we get some stuff here. And where is it? Okay. So we have the world mesh. Here we have the controlling. So let's rename this to the world mesh. So where are the... Also have this, which is going to be the world collider. And now let's rename them again to the controlling collider. So now we have the vertex colors here. Now of course we need to pass. We need to also give it some vertex colors, I think. So we want to give it we want to just give this thing a vertex color array. Vertex colors, because we need our vertex colors. So this is basically now going to be completely responsible for all those things that we want it to be responsible for. And maybe I should make this public, because the important thing So we need to set this dot vertex colors equals vertex colors. So now we have, of course, some vertex colors to go for. And we also need to set this as vertex colors. Okay, so I think this should be it. So let's just not do too much different. I'm just not going to set these. So let's comment out a lot of this stuff. And then we can say, you know, let's set a mesh controller. C equals a new mesh controller. And we want 0, 0 game world dot width dot vertex width, game world dot vertex height, and we want our vertex colors, of course, and we want a material, which is get component, which well, I guess right, so we need to also pass in a material, I guess. Material M. And that's going to be that, right? So we just pass in M. There we go. Cannot convert from Unity Mesh Collider.unity.material. No, you can't. Get component mesh renderer dot material. Okay. So now let's see if this works. I'm skeptical. Very skeptical. Yes. So where does that happen? It happens over here. Number overflow. Do we do something bad? Right. It's because we have this problem. It goes left, right, top, bottom, but I went left, top, right, bottom. No, left, bottom, right, top. So it didn't really like that. I get it, man. I get it. And now it's another overflow. So let's see here. So why is it going now? Right, top, bottom. It's top minus bottom. So it should be bottom top, right? Yeah, that makes sense. It shouldn't be top bottom, it should be bottom top. So there we go. Because the smallest should be first. Okay, so now there's no errors, but still there's no sort of thing like that. So let's take a look at Unity creating new game objects. Because we need a new game object. So the creating and destroying game objects. So yeah, let's see. An empty game object in code. Okay, so there's a problem, and that is that this thing doesn't create a new game object, but that is easily fixable. So we have our game object container. So let's see. And I think the best way to do this is to pass a game controller through to the renderer. I'm going to try and refactor some code later. For now, I just want this to work. So we have our game controller, and so we want to pass in this, and the same thing you have to pass into this now. So just passing the controller, and so I'm going to add that in here. Game controller, and now I want to have a game controller. So why does this have to happen? Well, let me show you. So this dot controller equals the controller. Now I don't think I need actually a variable that stores it. I just think that I need it when creating this, right? So all I need to do is say controller dot instantiate. What? I can't do that. Instantiate. What is going on? I need to instantiate. Object.instantiate. Okay. So I should just be able to say object.in. Why can't I instantiate things from that? That is annoying. That is really annoying. So am I using Unity Engine? Yes, I am. So I cannot instantiate apparently. So what is tree instantiate do? Tree instantiate dot new tree instantiate. What is going on? So yeah, I might have to do some weirdness here. Okay, so I want these mesh controllers to be children of the game controller. So I might have to say that the renderer, when we might have a renderer.create mesh, right? So you have to call that manually, and then it returns a bunch of objects or game objects array called objects, and then you have to pass that into there. That might be what so maybe we just, you know, for example, say create mesh, and then you have to loop through all of the objects dot length a plus instantiate objects I this dot just say the transform. So this is the parent. True instantiate in world space. Well, that doesn't really want to happen, and I mean, yeah, that looks about right. Yes, so now I'm going to have to say a game object array, and I also will just remove all of this because I don't need it. So let's make a new mesh controller, and at c.create mesh we need our container. So our container is going to be returned as a object when we say public game object get container, I guess. So we get a container, and all we do, return container. Well, I guess it might be a public thing. Why not? Or well, I mean, let's just do a public game object container, make it a getter, so that we can get the container. So, right, so we don't have an M. Why do we not have an M? Because we don't, apparently. Right, we don't have the material. That's annoying, isn't it? Oh, I mean, whatever, but container. So let's just have some game object array with all of our containers. So eventually, of course, I will refactor this. That's the plan later. But before I can refactor, I need to make it work as well, right? There is no point in refactoring until it works. Okay, so now we just return containers, and I shouldn't do it this way, but for now it should be okay. Yeah, hopefully. So let's see how this goes. Okay. Renderer.createMesh is inaccessible due to its protection level. Yes, in fact it is. That's not a good thing. Let's fix that real quick. Okay, so it kind of worked, and there's a thing here, and it has a mesh renderer, a mesh collider, and so on. And however, it doesn't have a mesh. The mesh is not instantiated. There's a problem, and that's because I don't call create mesh here. But other than that, it should work, hopefully. So that's nice. Okay, so let's see here. Still no mesh. Let's see. So the game controller is over there, and it has no mesh. Why now did mesh? Okay, object reference not set to an instance. Vert count. Yes, in fact, no. I have game world. However, I guess I never said it. No. That might be a good idea. Game controller game world, and this dot game world equals game world. Okay. So let's see. Right, and so we need to give it the parameter, and the parameter is the game world, so it's just the same thing. Ooh, okay. No, it still doesn't make me happy. Because implicitly assets.scripts.world game world. Okay, so apparently I made it the wrong way. It should be a world. There we go. Okay, perfect. Are you happy? No, you're not. Okay, that's just from the previous run. Okay. Okay, that works. That's really cool. Happy, happy, happy. Woo! Great. And I hope the stream works, because for me it's buffering. And that's not good. So what's going on? Okay, so now, okay, it's fine now. Good. That makes me happy. But yeah, it seems to be working now. That's good. That's really good. Okay. So let's try out some stuff. Just to see like what should be happening. So we have our world, and so now I want to figure out how many sort of world things I want. And sorry again, our internet is bad and I hate it, especially today for some reason. I don't know why. So that's bad. So yeah. Okay. Maybe I should check here just to see, so that the network, yeah, the network should be fine. It's just 3%, right? So it should be no problem at all. Let's see here. So here we have our network, and I mean, sure, but it doesn't look bad. Okay, sure. Okay. Interesting. There's a lot of stuff going on. That's bad. But okay, I'm just checking some stream stuff so that it's all working. So let's see here. Also loop that playlist YouTube. Otherwise I won't be happy. Well, maybe don't, because then I can sort of pick more different music later. Okay, so this seems to be working. Now, a big thing I think would be to make multiple. So let's try and do that. So first of all, I want to store the material, and that should be all I need for that sort of thing. So now we just need to set material equals m, and we can remove some of these deprecated variables that we don't need anymore. And the name C does not exist in the current context. No, it does not. So we can put that there, and then we put the material. Game controller. Why did I need that? Why? What am I doing with it here? Setting a controller. I'm not even using it. So it's a useless thing, basically. Okay. That sounds great. Let's fix that for you. And then we can just say we don't need the controller. And here we say this. Okay, cool. And this should still work. Now it's just nicer because I can create a mesh renderer without actually creating the meshes yet, which should help. And not set to a reference of an object. Which object? are you talking about? Let's see. So which one? Is it Vertex Colors? No, that should be set. Okay, so it's not doing, something is wrong. It's not doing something, it's not doing what it should be doing, which is weird. So one object is not set to a reference. Is game world? No, game world is in fact here and should be set. So is it Vertex Colors? Let's do a debug log here. Debug to see what's not right. Debug.log C plus colors plus vert C plus vertex colors plus game world plus vertices game world. Okay, so we have that. Let's try and run this and see what we get. Okay, so everything, so vert C, so vert colors doesn't seem to be anything, which is interesting. So yeah, why is that? We do set vertex colors here, so let's see. Debug.log vertex colors. Let's see what that gives us. So it's null. Okay, that's good to know. Really good to know. So that means that at our world renderer, at create mesh, what is null? Vertex colors, because I need to set them. This dot vertex colors equals the vertex colors. Okay, so now that should be fine, hopefully. Yes, okay, so I have our thing here. So now I just need to figure out a way to, well, implement multiple of these and make a grid of them. So that should be not too bad. And also, let's actually name these something, because I can't stand them being named nothing at all. So I should name this something like, let's see what I named them here. No, that nothing. Okay, so maybe like a rendering a world section, maybe. Yeah, so now it actually shows that there's a world section, and that's making me happy. Okay, good. Okay, so let's see here. So instead of setting up this, we should find the width and the height. How many we need, basically. So int sections width equals, I guess, the game world dot vertex width, I think, divided by how big the sections should be. And this should be a static variable, so static int called section width, or section size, I guess. And the section size should be something like, I don't know, 100 per se. It's just arbitrary values. There's section size and int sections height. And and I should make it n sections height. So game world dot vertex height divided by section size. Okay, horrible code, I know, going to be fixed in a bit. So let's take a look at what we need more. So we also need the x position, the current x position, and the y position, and that is going to be important as well. That should be it. So now we should loop through. So we should say n less than n sections width I plus for int j equals 0 j is less than n sections height j plus plus n sections. Something else I should do before I forget is also here. There is an important thing to do. That is, of course, to say here instead width times height, because otherwise we're going to get a crash. Because we're not taking the world width, we're taking our own width. So that is going to be fairly important. So tile height is just width minus 1. This is height minus 1. And so vert index is top, no, it's, let's see here, left plus bottom times height. And I think it's vert height. Yes, okay. So j is less than left, is less than bottom, and no, this is bottom and this is left. And here we have our, well, I guess I could just do it 0, 0, because we have vert height and vert width, which are correct. So then we'll loop through, we get those, should be fine. However, there are some weird sort of and strange things. For example, I need to set the vert index here back to left plus bottom plus j times vert height to make sure that I don't get weird sort of weird indices. The same sort of thing should apply here. Right, so you know what, this should be much cleaner if I just say something like so this is left, so this is bottom, top, left, right. And then I just say vert index equals j times I times j plus, no, I plus j times height, oh, vert height. That should be much nicer, I think, at least. So now we just say something like j equals bottom plus bottom, no, just bottom, and this is going to be left, and this is just a tile height. So yes, it should be top minus 1, right minus 1, or something like that. And this shouldn't be there, this shouldn't be there. Instead, I should just say vert index equals j times tile width, vert width. Okay, there we go. Tile width plus I. And here we have try index equals. So yeah, try index I should just add 6 to. because it doesn't matter which order it's in, it just matters that they're there. And that should be all. There should be nothing more required for that. Okay, that's good. Okay, so let's see if this works still. So let's make this width divided by 2, and let's just do that. And we also need to say containers equals a new mesh controller array. So game object array and c.container. Okay. And where did you expect that? There you did. Okay, so X is assigned but never used. No, it's not. Good that you pointed that out. And this clock is freaking out. Let's set it back to what it should be. Okay, there we go. And horrible. Absolutely horrible. This is the thing about this is life, man. This is life. Exactly what you want. All the time. All the freaking time. Like, what's even going on here? There are some really weird things happening. I don't understand half of them. So let's try and fix this. This really weird sort of thing that's happening. So we obviously set those there, and with this right minus left and top minus bottom, that should be correct. And that's width minus 1, height minus 1, should be all right. Times vert width, which should be just be width, but that's all right. Okay, I think I know what's wrong. Okay, so in some cases, yeah, here you can see we add vert width, which is completely not correct. So I should add another thing called lower vert, and so lower vert equals j plus 1. I guess it should be higher vert. It's the higher vertice times tile width plus I. There you go. So now it should be higher vert here instead of higher. No, not gonna like that. Higher vert. And so here's going to be higher vert. Here's going to be higher vert plus 1. Okay, let's see if that works. No, it does not. Right, that's absolutely horrible. And still that's not working either. So, what do you think is wrong? This is the question that has been bugging humanity for ages. Not really though, but yeah, so you can kind of see the colors, right? That's good. That's good, I guess. I don't know if that's a good or weird thing, but you know, you can see the colors. However, it's a bit sort of dragged out in this direction, and I think it's pretty clear why, because it does these sort of weird things. So what else could be wrong? So here we're setting the vertices, and vert index should be all right. Title width. Oh, right. This should be vert width. Because of the reasons, of course. And here to vert index ++ not required anymore. Let's try that and see if that fixed anything. However, I don't think, no. That wasn't even like a small part of the problem. So what's the problem? I don't know. Let's just try and see, you know, if it still works with a normally sized world. Because that should still work, right? Yeah, that it still works with that. So that's nice. So it's still sort of a relatively well-functional thing. And let's try and make it small. So the game world is still big, but this is going to be small, like a 5x5 small. And let's see what that does to it. So we have a tiny little area, and this is interesting. So right now it looks sort of fine, because I think, you know, it really starts to show when you get a bit bigger. Right, so let's see here. Yeah, so really what's happening, I guess, is that, yeah, I think I see what's happening. So, well, kind of. I'm not really seeing what's happening, but so let's try and make it like really big. So let's make it just the normal width. So game world dot vertex height, I guess. Yeah. Okay, so as you can see, it still sort of works. It's just really sort of oscillating a lot. And I'm not sure why it does this, but it seems to do it like pretty regularly. And let's see what happens when we expand the right as well. Let's see what happens with that. So yeah, it still sort of does the same thing, which is interesting. So let's also try to just move it out a bit and see if that does anything to change it. Right. So now it crashed, which is not a good thing, really. And yes, that is indeed because the right area was smaller than the left area, and so it went outside of the bounds, which is pretty obvious that that's going to cause an error. So here it's interesting. It for some reason crashes because vert index is out of range. So why is it out of range? And I think I know why. So I think I know. So the reason that it worked before was because I had a vert index could work for both the world and the vertices, but now it doesn't, because I made it smaller. I just have a subsection. So really I should also have a world. So this is the world one, and so I should really just have the vert width, and I should have the vert height. No, the vert height goes here. And so I should have the vert width, but then I should have the game vert index. So the game vert index does this, but it also adds the left. And then it adds the bottom and multiplies that by the vert width. And so if we have our game vert index as well, we can get some better results. And here we don't need that because we don't access the game world. So let's see what that does for us. Referencing out of bounds vertices, index count 11718. Vertex count 2180. And this is pretty safe to assume that this is pretty much the same thing. So this is just the tile height, tile width. So because here we are actually accessing our, let's see, right. Okay. So really we want to add the left. No, we don't. Because these indices are local, and when we add the left and the bottom, we get the global vertices. We need to make sure that we separate the two well, and I'm going to have to do that in the refactoring later. Okay, so now it works. It just doesn't put the game object at the right spot. So I need to do that when I create it. I need to make it work. So let's see here. Here we have it. So let's see if we can add more things. So we can add container dot transform equals dot position equals a new vector 3. It's going to be our left plus right divided by 2. So it's going to be left divided by 2f, right divided by 2f, 0 top divided by 2f, and plus bottom divided by 2f. So this is a way to get sort of a average. You just take each element and divide it by 2 when you're going to get averages by 2 elements. You can also add both and then divide them, but it doesn't really matter. I might do that later because it might be more performant. Okay, so as you can see, it kind of works, but also kind of doesn't. And a reason for this is because, of course, the Z location is way off, and it shouldn't be way off. So something is clearly not entirely right with that one. And I think I know why, because it shouldn't be the plus right thing. It should only be the left and the bottom. And the reason for this, of course, is that I'm generating from the bottom left, and I'm not generating from the middle. And now you can see it does in fact go on the right spot. So now we can move everything around, and apparently there is what? Oh my god, I didn't realize. Oh no, this is becoming too much, man, too much. So I don't need to instantiate them, I just need to say that objects at that position dot parent dot set parent, no, dot transform dot parent equals transform. So that's what I need to set here. Just make sure that no, well, I'll do that here for now, but later I'll just have to pass myself there, because otherwise it's not going to work that well, and you'll see why. So now, instead of instantiating them, I'm actually just setting myself as the parent, so that I don't have two of each, which is kind of stupid to have So I'm happy that I don't have that anymore. That's quite the nice thing to make sure of. And you know, I could like put this here and do stuff, you know, so I don't know. Let's see. So now I need some more bug tracking here. So I need to find a bug that we have. So still, if I put just the normal game world width, it should still work just as expected. I just want to make sure that, yes, indeed, it does not have such a tight sort of up and down motion that it does in the sort of thing that I'm testing at. So let's stay. I think I'm seeing something here. So let's take a look. So I got this. So let's comment this out for now. Let's copy this down. Let's make this one a 10. So now we should see that it goes much shorter, right? Yes. And I think the reason for this is that I'm actually, because so the algorithm moves sort of up and down all the time, and I think the reason that this one does is because I mixed up in some place the z-axis with the y, the z and the x-axis. So let's just try again and do 100. Just make sure that it's actually that sort of thing. So if you go 100, no, it in fact goes much faster. What's going on here? So for some reason that I cannot seem to understand, it goes up and down, up and down, up and down really fast, and does that. But it sort of does it in line with the thing. It's actually kind of pretty. So that's kind of neat. Cool. So let's see here. Maybe I could try and rewrite most of this code just to make sure that I sort of understand it still. So with our new sort of thing, this should still be the same. Let's just remove all of this code and see where we can get if we rewrite it. Because rewriting code usually makes sure that you sort of understand it properly. So what do I want? First I want to create vertices. And as I create a mesh, I actually want to instantiate my vertices over here. Create arrays. And do I want that? No, because I might do that in some sort of set width function. Anyway, so create vertices. I want to first have how many vertices I want to create, and I want to create basically all of the vertices. So we do just width and height. Okay, and also something that I want to do is just make sure that I know what this means. So it's vertex vert width, and rename vert height. And here I want to say vert left, vert right, vert top. No. Vert top. And that's not it. So I want top, rename vert top. Okay, there we go. So now rename vert bottom. Okay, perfect. So let's take a look here. Take a look. So I've got my vert width and vert height. So let's say instantiate some useful variables, and I want to get the local vert I, and int local, int global vert index, and I also want to say int local tile index, I guess, and that should be all I need. I might also want int try index, try I. So let's see here. So now I want to say local vert I equals I plus j times vert width. So then the global vert I, and in this case it should be I plus left, vert left, plus j plus vert bottom times game world dot vert width, vertex width. Okay, so now you can see we get the global vertex index and the local vertex index. So now we want to say that the let's see, vertices at the local vertex index. That's a bit of a tongue twister, not gonna lie. So game world dot vertices global vertex index dot height, and I want to actually declare that in a variable, so let's do that. So we want to have a vertex, a world dot vertex handling vertice, yes, or read vertice. So I want to say read vert is nice. So read vert equals game world dot vertices global vert index. It's not much, just to say read new vector 3 new vector 3 and maybe an integer, because if I make these integers, which should help vector 3 int. Okay, so I apparently can't do that. Well, that sucks. Okay. Anyway, it would have been fun to do that, but I don't want to do a bunch of transforming, because that way I can't mess up and do like weird graphics that I shouldn't have. So that's nice to have. And so I should just have the I plus vert left, j plus vert bottom, and of course I also want read vert dot height. Okay, perfect. So now we also want the colors. So colors, local vertex index equals a new color 32, and it's going to be the let's see here, it's going to be the vertex colors at the local at the read vert dot type. So we want to just get the color of the type. Cannot implicitly convert type assets scripts.vertex type to integer. Right, so I need to set cast this to an integer. Okay. So that should be fine. Now I want to create triangles. So this is going to be a bit more tricky. So first I'm going to set it to 0. And I'm going to go through all of this, but I also want a tile width and a tile height, just to make sure that I've got all of these things that I want. So tile width is vert width minus 1, tile height, vert height minus 1. Cool. So I've got my tile width, and for int j equals 0, just need some tile height, j plus plus, I plus plus. Now, I think, you know, just because I'm doing it in other places as well, I might just want to invert these loops. Because it doesn't affect me right now, but when you do sort of, you know, try index, try I plus equals 6, it might help to do so. Okay, so now I have a local vert I, vert index, equals I plus j times vert width. Okay, so now we're just going to say that triangles at triangle index plus 0 equals vertices at the local vertex. Now let's see here. Go to local vertex index. Yes. Let's see here. Yeah. So I just want to say local vertex index. Okay, so let's just see here. I just want to have all of these and just add 1, 2, 3, 4, 5. Okay, so let's take a look at how this worked again. So I have this, just an ugly thing on a bigger pencil. So I have my thing here, and so here we have the 0, 0 point, 0, 0. Here we have 1, 0. So we get one step to right. Here we have 1, 1, and here we have 0, 1. And so here we add width, and this is just a 1. Right, so we want to start with this one. So we want 0, 0, 0, 1, 1. Well, let's start with this one. So it's 0, 0, 1 width plus 1 and 1. So we want first 0 plus vert width plus 1, and then plus 1, right? Here we go. Yes, indeed. And then we have 0, 0, width plus 1. So it's 0, vert width plus 1. Local tile I don't need that, so let's remove it. Let's see if this works now. And the code for this one is starting to look like okay, I guess. So, you know, that's good. So let's this code we don't need to work with right now. So let's see if this works first of all. And it looks like it does. So let's just try and get like a subsection. So if we get this area, you know that's a hill. So let's see here. I'm super excited. It hasn't worked yet, so that's going to be nice. So let's do 50, and let's do like 50 and get 100 here. So we're going to get a small subsection of the world. And indeed, this seems to be working. It's a bit off from the mountain, but yeah. So this is awesome, right? Absolutely awesome. So now we can start getting the full amount of, we can start generating the entire world, which is going to be cool. Let's see here, more music. Okay, hang on. So there's 18, 17, 16, 15, 14, 13. Let's do 18 is pretty good, I think. Okay. So, right, so the music I'm listening to is some crinkles. It's really good. Really chill, which is good for coding, right? You don't want super tense music. You get tense, and tense is not, being tense is not good for coding. Exactly. So first we want to go through all the sections, section width, section height, and so on, and then I think at the end I just want to add right, so let's just try this, and then we'll do some work later. So we need some x value, some y value, and now we're just going to add x plus equals section size, y, and here we do y plus equals section size, here we do x plus equals section size, and so here we say y equals 0, and so here we also want to say that the containers equals a new game object array, and I also want to clear all of the objects in the containers. So let's first do that absolutely first. So first clear all objects in the game objects in the containers array. So if containers is not null, because we want to make sure that we actually have stuff in there, then we go through it all. For int I equals 0, I is less than containers dot length I plus plus, and let's go backwards because I'm not sure about this, but if I'm not sure, then I should make sure that it's safe to and then we want to destroy that. So maybe I should do like this dot destroy. No, you don't want me to do that? Dot game on. Yay! This. Where will we find the latest game objects? This is fun, man. That's comedy. I should leave one of those like massive stacks in there just for fun. But I mean, I don't know how to remove them if I don't have sort of a. Maybe I could do like object dot destroy. No, game objects dot destroy. Okay, destroy. And so we destroy this object. Cool. So now we're going to destroy it so that we don't have any more. Right? So that's just for cleaning up some memory, if there's any. So containers equals a new game object array. And how many elements? Well, that's of course n sections width times n sections height. And so now we say int let's see, section index, int current section. And so here we can just say current section plus plus, and here we just remove all of this and we return containers. Good. So now I say containers let's see, current section equals, so we want to say something like, okay, so I'm not currently storing any mesh controllers, which is not great, but it's just mesh controller C equals new mesh controller, because later I'm gonna store all the mesh controllers instead and destroy all of them or their game objects, and c dot container. So now I want to create it, and it's going to be the x plus, let's see here, x plus section size, y plus section size, and they're also going to be the game world, of course. There's going to be the vertex colors, which is going to be just the vertex colors, and we also want the material, which is going to be the material. Okay, so all this should work, and so we have section size, we create world that's fairly large, and let's create this and see if it works, which it probably won't. No, in fact it does not. So where are the other ones? So I mean they clearly do all of their things, but you know, so what's going on here? And also, why does it have 40,000 verts? Some indices are referencing out of bounds vertices. That must mean that something is wrong here. Local vert I, we do tile width, tile height, those should be fine. So why is that going on? So let's just do mathf.floor to integer this thing. Or well, let's make this a multiple of 100 just to make sure. And also plus equals section size. Yes, that should be fine. So we make it a multiple of that so that it doesn't have weird rounding errors. So now it should be 9 elements. Let's just see if that is the case. So indeed there is 9 elements, and here we have one section which is like a massive section, and I mean it seems to be about right. It seems to have one section with 40,000 vertices. Why are there 40,000? I don't get this. There should be about 10,000 because 100 times 100, but there's 40,000. That's strange. something's clearly not entirely right. However, I might be wrong. Maybe there should be more vertices. I'm not sure. And this one is small. So why is there a big one and a really small one? So that is strange to me. Very strange indeed. Right. What? Where are the other ones? So here we have a section, and it's just layered on top here. It's the same section. Why are you there? Right, so something's clearly wrong with my sort of layout code. It's not laying them out like it should lay them out. Well, this is obviously said. Wait just a minute here. I forgot, it's not XY with height, it's left, right, top, bottom. And here we go. So this is almost correct, just that, right, so let's take a look here. So this is 100,000 vertices, so this is the correct size for them. They're just laid out a bit too scarce, but otherwise, other than that, for example, if I put this here, you can see they do in fact fit together fairly well. So if I just put them together perfectly, then it in fact does look pretty neat. So that is nice. Right, so if I actually make the math correct, then that should be relatively seamless. So let's take a look at what's wrong here. So we're adding section size. Right, so that should be fine. So we're always adding 100, and 100 we are in fact adding, because this is 100, this is 100, 100, 100, 200, 300, 300, 200, 200, so on. So yes, that does work. However, I guess the vertices are just too small. So, I mean, for example, if I make a, let's refresh here. So, for example, if I make a cube here, create empty, no, not empty, let's create a 3 object and a cube. So let's take a look at the cube here. So the cube, so I have him here. Is he one vertex? Yes, he is. So technically, if I scale him up to 100 by 100, he does in fact cover this full thing. So this thing is in fact 100 by 100, pretty exactly. So why then, wait a second, this is fun. So I put material, make a new material, which should be transparent, and I should put some transparent blue, right? And then I should apply that material to the cube, and then I should move the cube up a bit, and boom, we have water. Ha! Okay, that's fun. That's funny. Woo! Look at me, so funny. Yay! So make it 600. Well, 500 apparently, by 500. And it covers the entire playing field, and everything gets a nice beautiful coat of water. So yes, if I make this really large, so maybe I should make a plane here, right? This is just playing around. I mean, it might be a nice way to just have a sort of a temporary thing. So maybe we make it like 1000 by 1000, and we make it a blue color. So we just have a C, so that you can play around with it. Yeah. Okay, so now we just have like nice water to have for our world. Right, of course I'm going to change it, but yes, I think it might be nice to just have it. Cool. That was unplanned for, but it worked, which is nice. So now we got water, apparently. Bad water, to be fair, but it's water. So where is my calculation for the position of the thing? Because obviously maybe it's the world game controller that is weird. No, it's not. So in the mesh controller we have left and bottom. So yes, this should be all right. So why is it not all right? Why does the Z and the X go up by 2 instead of 1? That is really, really strange. And I don't understand it. So, what if I just set them here? So it's I times section size and Z equals J times section size. Just to see if this works. No. So the question is, right, because they are in fact 100 by 100. That has been shown, right? And they are 100 and 100 by, from each other, and these one are 1 by 1. So this doesn't make sense. Something is wrong. And that's something, I think I get it. Yes. Indeed, I think I do. Okay. So I think I know what's wrong. That's because in the mesh controller, I think creating the vertices, I made something wrong. Yes. In fact, I did. It should not have an offset, because this offset made it double as wide as it should be. Because we're setting its position, so we shouldn't need to set its other positions as well. Okay, I think that's going to fix it. Yes. But as you can see, there's sort of a thing here that's not covered up completely. And this can be solved by just making sure that we're taking this -1. No. Yes. Yes, no, yes. So let's remove that. So let's see. Yes, so we can add 1 here. And so doing this now, we should also make this like 301 by 301. Just make sure that everything is correct. And indeed, it sort of lines up now fairly well. I mean, some of the shadows are a bit weird, but in general, you can't really see the seams that well, right? So the seams are, it's fairly seamless. There are some seams, but overall, you know, for the gains are much better than the losses. Now, of course, the section size is fairly small, 100, right? So we want it to be 200. And I might also make a much bigger world. So let's make it 1001 by 1001, right? And then, of course, we'll also need to deal with sort of not completely uniform worlds. But yeah, look at that. That's a massive world, and it runs very well, right? So let's take a look at the stats, right? It still runs at really good FPS. That's interesting, right? I didn't think it would run that well, but apparently it does. So as you can see, it's split up into sections and everything works. Now, let's add the water again, because the water, I think, I at least thought it was fairly nice. 1000 by 1000, and also it's going to be at where the water level usually is, so something like that. And yes, maybe a bit higher up, and also apply the material. Yes, so now indeed, well, we should probably add 5.5 so that it doesn't it isn't exactly at a certain layer. And now, you know, it's a bit, the water is a bit high maybe, but I mean, this looks fine to me at least. So yeah, this I consider a success. So now we just need to do some refactoring, because now the code is sort of working and it's all fairly nice and neat. So now I need to do some refactoring, and first of all, a bug fix. This thing, first of all, the mesh collider isn't being set. So that's the first thing, and the most basically simple thing we need to do, I think. So we have our mesh collider, and at the create mesh, I am in fact checking if it's not null, but I'm not setting it, so I should probably just set it equals container.get component mesh collider. And if I do that, then I should also set something like container.layer equals layers equals ground. No. Layers dot, no, sorting layer dot name to ID and ground. So let's see if that works. Possibly. Okay, so it's set to default, but if we set it to ground, then, I mean, if we move the camera there, of course. So we move the camera over there. And also that world section should have a mesh in the mesh collider. Yes. But unfortunately, it doesn't seem to work, even though the layer is ground. Which, I mean, that was what used to work for things and such. So I'm not really, I don't really understand what's going on here. And also, wait, oh, I see the minimap cam. Whoops. 0, 0, 0. Let's do the main camera then. the main camera is what needs to be moved. Man, that's bad. Bad, 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 bad. Okay, so I mean it kind of works, yes. However, I think I might just need to do something like, let's take a look at the camera player control here, because here I am in fact doing that. Okay, so I'm adding one, which should hopefully do that and make it work. So now it takes a long while to load, and they're on transparent FX. So maybe not. Wait, oh. So I need to the world renderer ground +1 bit shift 8, and also let's take a look here at what ground is. It's 8. It's called ground. Joel, du får gå. Joel, du måste gå. My little brother came again, right? So he's coming now and then and just doing something. I don't know what. Right, let's just try 8. Hard coding it. I should probably not make the world so big. But yes, okay, so this works. Great. That makes me happy. So now everything is sort of functional. And let's see, the plane is on default. Okay. Yeah, so it seems so the you move over water. Let's try and sort of water, and let's try and sort of make it more transparent, because sort of the water is a bit too transparent. Maybe a bit more greenish. That would be interesting to sort of make it different colors. But of course, this isn't sort of final water, obviously. So let's make it a bit darker blue and okay. So maybe I could have some sort of reflection as well. So reflections, okay, good. So let's see. No, you can't see it. Whatever. It sort of works, I think, right? Oh, damn it! I need to wait for it to load again. But yeah, I mean, it's all right. It's all right. Of course, I might want to do something like a bit less, because less is more, right? Less is indeed more sometimes. That should take about half as long, which is still fairly long. It's just not to bore you guys, right? This is sort of just. I mean, I'm technically I've done what I should do today, so I guess I should just sort of continue with what I want to do next. And let's make it a bit more transparent still, which should help make it sort of neat and nice. And if I sort of make it a bit more sources, then we'll have more sort of sun reflection in it, which is nice to have. So there we have the most sun. Okay, That's great. What if I have like specular setup? Okay, that's pretty nice. I mean, sure, but it's a bit weird, but I mean, I like it. Anyway. So, so I was going to refactor. Because, first of all, this is completely unacceptable. I was supposed to make this hidden for the game controller, but now you can clearly see that I need to do something. So that's completely unacceptable. And also, bam, dead, bam, and this thing should not require these components anymore. And all it should need is like a material, a public material, world material, and we should not need a mesh. We should only need the world material, and not a mesh collider. So, you know, in the world renderer, of course, we should just clean up some stuff that we do not need. So we don't need a world mesh, we don't need a world collider or anything like that. So the game vertices don't exist. What? Did I just remove a bunch of stuff from here as well? Damn it. Vector 3 array vertices, color 32 array colors, and int array triangles. There we go. Okay. What? The controller. What was the controller before? Right, so it was a mesh. So it's what we were controlling. So we mesh controlling and collider, mesh collider, collider. Syntax error, something expected. Right. Okay, so you're fine with that. Let's see how you run. Pretty nice, just I forgot to add the material. So I need the ground material for that. That should work. Yes! Nice and beautiful. And also, just because the main camera can be a lot further up now, because of course the world is much bigger, so we don't need such a small puny camera. Right. However, that might be a bit too much. About this size is fairly okay, I think, right? It feels fairly open and neat. Yes. Right, so I just want to know this doesn't feel like crammed or anything, because I don't think so. I think it looks relatively nice, and also this minimap camera should have a bit of a larger sort of view, I guess, and should be a bit bigger as well. So you can see a bit more stuff when you have it. Alright, nice. So maybe 100. Okay. Okay, good. So as you can see, we have like nice minimap. The minimap is just a render texture that I did before I started streaming this development process, I think. But yeah, let's continue the refactoring process. So we need to make sure that this doesn't happen, because we don't want to have to get all the objects and all of that weird stuff. So let's start by just creating, instead of having game objects, containers, we want to have a mesh controller. And I want to rename this to controllers. And so instead of saying controllers I, we say controllers I.container. Ooh. And then we also say controllers, also a new game controller. And here we just say C instead. And this allows me to remove this temporary variable completely. And I can just set that as a variable. Cool. And it cannot implicitly convert that. Right, it's a mesh controller, not a game controller. Good to know. Thank you. And world renderer.mesh. Because we don't want to return anything. We want to do none of such. So let's just remove this. Good. Okay. That's nice. Because notice here we have we don't actually use a game controller, but we pass a game controller here. So we have the world. We also need a game controller, which but the thing is, I don't think I want a game controller because I'm not using it. I may only want a game object, which is going to be sort of the world. So maybe game object, sort of world storer, world mesh parent. That sounds good. So we have Vertex Colors, we have the controllers, we have the mesh parent. Yes, that should be the order. So we have so here we have some visual stuff. We have some. Why do I need that? Okay, that doesn't need that. I don't need it. That's cool. So right. All I really need now is I don't need to pass a material. No, vertex colors are needed. So let's just mix up some orders here. So we pass first in the main thing, and then we pass in a world and a thing. So now I have just the controller dot material, world material. Now I also want to have a game controller, the controller. But the problem that this does is it game object. So I want a game object that's going to do it. Game object, because it's going to have the mesh parent. Because I don't want a controller. So I want to pass a material. And so why I'm doing this is because I just realized if I want to use this without using a game controller, for example, if I want to make like a preview map or something, sort of just like preview a pre-generated map, I don't want to have to be bound to a game controller that does all the physics and stuff just to render a map. Then I can just use the world renderer, a world generator, and a player control, and they together will work perfectly fine without the need of such measures. So here my passing arguments are completely off. So we need this as a game object, and that we don't want this here. from, so this starts the game objects. Here we go. So that should be about it. And so let's take a look at one more thing that we need. And that is going to be that the controller's current section dot container dot transform dot parent equals the, let's see here, the mesh parent dot transform. So we want to set some transforms, and now of course we'll say this dot mesh parent equals the mesh parent that we were given. And so let's finally see what our refactor code does. Nothing. Absolutely nothing. That's what you like to see when stuff goes absolutely horribly wrong. Okay. So what could be wrong? That is the question. So, why exactly does this happen? I do not know. Let's make it a bit bigger. So, what could the problem possibly be? There is a let's debug that log controllers current section, and then I'll need to do some more stuff as well, but I'll show you that when I get to it. So apparently it's not working, which I don't understand exactly, because the game controller has all the things it should need. So the world, let's take a look at what the console gave. So absolutely nothing. Oh, right. I need to actually, I need to create the mesh before I can use it. That is the simple principle of which I operate. Okay. There we go. That's perfect. So we create this giant world, which is, even now, which is like, this is a fairly small world. It's like bigger than the biggest world I made before. So I mean, this is I would consider a success. However, let's take a look at some examples of some weird behavior. So let's say I make 450. It's not going to be 450 by 450, but instead it's going to be much smaller. Or it's even going to crash. No, it's not. It didn't crash, but let's see here. So since it starts at 0, 0, this point right here should be how wide it is. So let's create a 3-object cube. We're going to put it right over here, which should be at 400, 400. Should make it a bit higher. So as you can see, it's about 400, but it should be 450. The reason for this is because we're doing it in these sections, and I can't make a section here because it's too small, right? This is, if we make the cube 450, 450, you can see that, as you can see, this cube is sort of intersecting right here, so we can't make a full one, so we need to make sort of a smaller one. And this is not too tricky, it shouldn't be too bad. However, it's still going to require some weird sort of tricky to make it work. So first we need to make these floats so we can get floating point division. And then we take mathf.ceiling to integer, which will hopefully make this a bit nicer. So this should, in theory, make it much more sections, but if we run it now, you can see it's going to crash. It's going to sort of cast an error because it's out of range. There's not, there are basically, after this one, that one goes outside the boundary and it doesn't work. So that is a problem and we need to solve it. So how do one go about solving this? Well, it's not actually that tricky. I just made it look like it was tricky, but it's really not. So in here we can make another variable. So let's rename these. So this is left, this is right, this is bottom. So we can make int top and int right and top as well. And these ones we don't need to assign because they're always going to be, well, almost always going to be a bit like just as much bigger. So here we're going, I'll tell you what I mean eventually. So we have our bottom, we have our left. Don't need to assign the bottom because we are assigning it here. And so here we just do left, but now we're going to do a right. So we do a right one, and we don't need this anymore because I'm going to show you why. So we have our left, right, and bottom. So now we can say that right equals left plus section size plus 1. And top equals bottom plus section size plus 1. Now, this is the interesting part that we need to make sure is that right equals right larger equal to n sections. No, it's larger equal game world dot vertex width. Right. So if it is larger, we set it to the, or larger or equal to, set it to the width -1. Otherwise, we just set it to right. And that does work. So now we do exactly the same thing for the bottom. And I should probably make this move down. So now I do the bottom equals bottom. No, top. Top equals top. Top, and then it's height. And this is the left. Here we have the right. Yeah, left, right, bottom, top. So that should be everything. Let's try it out. Yes, so in fact, let's see if the same cube is in fact at 450 by 450. And as you can see, the world is as large as it should be. And it's pretty perfect. So that makes me happy. Let's go. So now we can make any sized world as we want. Does not matter, it will always work. So let's make like 42 by 2000, right? Something crazy, really big, And let's see if that works. Okay, so it already generated. It's not that much though. So let's see. So it's split up. So it's just one section so wide, I guess. But there's a ton of sections going up here. And that's what we should see. So that is pretty neat, I would think. Right. So, you know, apparently they are not on the ground anymore because I cannot move them, which is strange. Well, I guess that might be some sort of weird thing that I somehow managed to do. Right? No, it still seems to have the same sort of weird thing that's going on. I don't know what's happening. I guess the origin got messed up. Maybe I just need to set it up beforehand to make it work. Well, that was too much. Here we go. Because, you know, I want to... No! Why does it not work? What is going on, man? Oh! Oh, there's an error! Where's the number overflow? Okay. So something is clearly wrong. But what is wrong? And why is the number overflow right here? That is the weirdest part. Right, so why is it right here and not anywhere else? Why does the number overflow happen right here? Oh, I think I have a sort of a theory. And that is that the last world section, right over here. No. But my sort of my theory was that there would be like a section that has no sort of width at all, but that doesn't seem to be the case, so I don't really see what would be wrong, right? That doesn't really make sense to me. What is wrong with this? And of course we can still move around. Right. So what is wrong with this? That's not the scale that I want. Okay, so I don't see it. Sort of why this doesn't work. I really like though that the water, even though this is the same sort of plane, has a different color depending on whether it's behind the sort of sky solid color or the ground. That makes it look really sort of legit. Though I need to add waves eventually, because this is just bland and boring. Boring water. We need exciting and violent water. That's what I want. Give me. Give me, give me, give me. Could it possibly be that it doesn't like the sort of size of it? That might be what it doesn't like. So if I take a look at this one and I make a cube, it should like function fairly well. Now something that is annoying me is that sort of, well, I guess, no, it does in fact line up. Okay, that's really good. I thought it didn't line up and I was like, no, please line up. If you don't line up, I'll be mad. I mean, it doesn't actually line up all the time. It only sort of really closely or just about lines up, which is interesting. Right, so it's this water is sort of freaking me out. I don't really get it. Just click on it and it cycles between them. That's weird. Weird mechanics, I guess. So yeah, I'm actually extremely happy with this, just not the fact that we're getting a number overflow apparently here. So what's going on? Debug.log. So I think really the problem is that, which I actually suspected before, was that let's just do the vert width and the vert height, was that these would be 0, in which case it would be kind of pointless, absolutely pointless to have them. So yeah. So the last one. So there's actually supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's only 10 because one of them. Because if it lines up perfectly, right? If it's perfect fractions, let's just do 200. Then it's going to also complain because it's perfect. So it takes this extra 0 as well, which is a massive problem, and I do not like that at all. So how would one solve that issue? That is interesting problem, I think. So is it here? Mesh controller? No, it's further up. Okay, so here we have it, the code, and here is that. So basically when these ones are perfectly aligned, then for the 200 it will return a 1, which then the ceiling will move up 1 step, apparently, which I didn't think would be a problem, but apparently it is, which is not a good sign. So the question is what to do. Well, I think so. If right, I guess I have to like implement it into this sort of line of code. So I guess I could do some sort of weird math. Maybe I should make a function. Not really sure. Let's make a function. Public int sort of ceiling divide, say ceil integer or int ceiling, and so the int ceiling will basically get an int a and int b, then we'll return the math f.ceiling, but ceil to int. from float A divided by float B. However, something that's important is to note that if the right, I think I have a better solution, which is basically, you know, I take the normal one, sort of A divided by B. However, I say that I add, so if A and B equals is not 0, so basically if the remainder of this division plus is not 0, then we want to take 1, otherwise 0, and add to that. So now let's try that. So we have our int ceiling, and we do the int ceiling instead. And so we just need to apply these as parameters, which should be functional. Should work rather. There we go. So that's a bit shorter line as well. That's nice. Well, it's nice to have shorter lines of code. So let's see. And it still does the number overflow. I don't know why. So what's exactly going on? So we have A, B, and A modulus B is not 0, but in this case it should be 0, because there is the section size is 200, the vertex width is in fact, well, vertex height is in fact 200, so the height should be 1 because it fits once. This is in fact 0, so let's, you know, if it's 0 then 0, otherwise 1. So let's do debug.log. We do A plus B. Let's do some sort of notation here as well. So AB plus B. Also do modulus plus A mod B. Let's see if that works. And also a semicolon. Let's not forget the semicolon. So, okay. So apparently, right. That's the problem. Okay. So the thing about the section size is that it should be the tile width that we should get for the sections. Okay, this is actually interesting. So the tile width is 1 smaller than the other width, and so that means that these ones should now be fully functional. Yes, indeed they are, because that is a 0 remainder of 0, so that's really good. Okay, well, let's leave that debug in there. So let's do 201 and see if that works. Hopefully it will, and not crash. Yes, indeed it will. And we'll have a tiny world section that's 1 unit long. Well, not even that. It's 0 units long. Well, that's useful, ain't it? That's very useful to have. Well, whatever. I mean, it works. If it works, let's be happy. If it works, I'm happy at least, and you should too. You should be happy too. Alright. Now, let's go crazy. Because I like going crazy. It's a pleasant feeling. Let's do a 2000 by 2000 map. Just to sort of see how it works. So, it's time to wait. You know, fun waiting time. Okay, here we go. And so the stats, you can see the frame rate is still high. So I think the frame rate won't be an issue for this game. Just a hunch from the frame rates I've been getting so far. So yeah, it looks really nice. However, no, okay, the frame rates are bad. The frame rates are really bad at this sort of scale. Okay, I just wanted to make sure. But I mean, it makes sense. Each single one has 40,000 in this vertices. And there are, let's see here, there is a 10 by 10 grid, so there are 100 of these, right? That is pretty massive, if you ask me. If you ask me, that's pretty big. 10 by 10 grid, each cell having 40,000 things. And you know, I can never sort of, I can try to get to the other side, but it's going to be fairly annoying. But yeah, I'm happy with this. So let's maximize, and we get a fairly okay. So the frame rate is actually decent if I don't have the editor and the inspector open, I guess. So that's nice to know that the frame rate is better. Cool. So yeah, I'm happy to announce that this video or this stream is officially over now, and it's once again sort of the same note that I ended on last stream. However, now I don't end on a bug or a sad note. Now I end on a happy note that the bug is finally fixed, and next time we can move on to something a bit more exciting. And I think next sort of part is going to be about terraforming, basically changing things. Now that's still not going to be too exciting, but I think it's going to be an important part, an important sort of stepping stone in the road to getting to a full game. So I think that's going to be a very important sort of feature to have in the game. So if maybe on Friday, I'm not sure if Lundare has announced the theme yet for Friday. I think it's on the night of Friday or something, so I'm not sure. I think it starts on Saturday. So if that's the case, which I think it is, then I'm probably going to run another stream where I'm going to implement terraforming. Otherwise, it'll be on Monday, and then I'll also do probably some streams playing some other Lundare games, because I want to, you know, playing Lundare games is kind of fun. Lots of basically quantity over quality, I guess, but you know, it's sort of okay. So yeah, let's see if we can find some artifacts. Well, here you can clearly see a borderline, so I'm not sure how to fix that sort of lighting issue. And also, the borderline doesn't seem to be perfectly aligned. Well, it does actually seem to be fairly good, well aligned. It might just be sort of the weird shader I'm using. I'd have to get a better shader that doesn't look like plastic. But yeah. So that's a 2000 by 2000 world running at about 60 FPS or 70 FPS on a pretty not great computer. Well, it's actually fairly good. for like our standards. But you know, if you think about like 10x gaming rigs and stuff like that, it's not the best. Definitely not the best. You know, you can get computers for like 20,000. Those would be better, of course. But yeah, I consider that bug for going over the vertex limit officially fixed, and also some really nice, also nice water, like 10 seconds water implementation, I guess. Really sloppy and boring, but still sort of fine. And also random console popped up. Want to close that down, Unity? You won't let me close it down. What am I gonna do with you? This is annoying. Really annoying. Let's just close you. Close you. Right. And also more artifacts. So yeah, once I switch shaders, that should not be a problem. At least I hope that won't be a problem. Oh, you can even see it through the water. Man, this isn't too great. But yeah, thanks for watching, everybody, and bye.